In the vast silence of the universe where time has no urgency and motion happens slowly, almost patiently, countless stars are born and fade away without ever being noticed. Galaxies drift through space like ancient rivers of light, each one carrying billions of worlds within it. Among all of these worlds, scattered across distances too large to imagine, there is one small planet that tells an unusually long and complex story. A story shaped not by intention, but by chance, repetition, and time. Earth was not always a place of oceans, forests, and living creatures. In fact, for most of its existence, it was something entirely different. To understand how life became possible here, we must let go of the present moment and allow our thoughts to drift backward, far beyond human memory, far beyond history, into an era when even the Earth itself had not yet fully formed. Nearly 5 billion years ago, the solar system was a chaotic and unsettled region of space. A young sun burned intensely at its center, surrounded by a vast, slowly rotating disk of gas, dust, and fragments of rock. Nothing in this environment was stable. Particles collided gently, then violently, breaking apart and coming together again, guided only by gravity and time. There was no clear beginning and no clear direction, only motion, accumulation, and gradual change. Within this disk, small fragments began to gather. At first they were no more than drifting pieces of rock barely holding together. But over millions of years, as collisions continued and gravity strengthened, these fragments grew larger and heavier. Each impact added energy and heat, turning the growing body into a molten mass. This was the early Earth. Not yet a planet, as we would recognize it, but a glowing, unstable world still finding its shape. At this stage, Earth was a place of constant violence. Its surface was entirely molten, reshaped again and again by relentless impacts from space. There was no solid ground to stand on, no atmosphere to breathe, and no water to soften the landscape. The sky, if one could call it that, was filled with fire and debris, and the concept of day and night had little meaning. Then, in a moment that would permanently alter Earth's future, another world crossed its path. A planetary body roughly the size of Mars, often referred to as Theia, approached the young Earth at tremendous speed. When the two collided, the energy released was almost unimaginable. Vast portions of Earth's outer layers were torn away and thrown into orbit. The surface was reshaped, the planet's rotation was altered, and space itself briefly filled with glowing debris. Over time, slowly, silently, this material began to gather once more. Gravity pulled the fragments together, and a new celestial body formed in orbit around Earth. This body would become the Moon. In its early days, the Moon hung much closer in the sky, appearing enormous and dominant, exerting a powerful influence over Earth's motion and internal balance. As millions of years passed, Earth began to cool. The constant rain of impacts slowed, allowing the outer surface to harden. A thin crust formed, floating atop a restless interior of molten rock. The planet was still hostile and unstable, but for the first time it was beginning to resemble a world rather than a furnace. From space, Earth would have appeared dark and scarred, its surface glowing faintly in places where volcanic activity continued to break through. The atmosphere, thick with toxic gases, offered no protection. And yet, despite all of this, The foundations for something extraordinary were quietly being laid. Water began to arrive, delivered by icy comets and water-rich asteroids that struck the planet again and again. With each impact, small amounts accumulated. Over vast spans of time, these contributions added up, filling low regions of the crust and forming the first primitive oceans. These early seas were hot, turbulent, and chemically active, unlike anything we would recognize today. It was within these waters, far from sunlight and surface chaos, that Earth's most important transformation slowly began. As the surface of Earth continued to cool, the planet entered a long and uncertain period of transition. The violent chaos of its earliest years began to slow, not suddenly, but gradually, as if the planet itself was learning how to settle into a more stable rhythm. The crust thickened in places, fractured in others, and beneath it molten rock continued to move slowly, carrying heat from the interior toward the surface. Water, once delivered in scattered moments by distant visitors from space, now had a place to remain. Low regions of the crust filled, forming vast bodies of liquid that stretched across the planet. These early oceans were warm, dark, and restless, constantly stirred by volcanic activity and powerful tides created by the moon, which still hovered much closer to Earth than it does today. The movement of these waters mixed minerals and chemicals in endless combinations, creating an environment rich in possibility. Above the oceans, the atmosphere was thick and heavy, composed mostly of carbon dioxide, methane, ammonia, and other gases that would be deadly to modern life. There was no oxygen to breathe, no blue sky, and no protective shield from the sun's radiation. Lightning flashed frequently, storms raged across the surface, and volcanic eruptions sent plumes of gas and ash high into the sky. From a human perspective, this world would have seemed entirely hostile. And yet beneath the surface of the oceans, far from storms and sunlight, something remarkable was quietly taking place. Along deep cracks in the ocean floor, heated by Earth's internal energy, hydrothermal vents released streams of hot, mineral-rich water. These vents created small, localized environments where chemistry behaved differently, where heat, pressure, and dissolved minerals combined in stable and repeating ways. Here, molecules interacted again and again, forming more complex structures with each cycle. Over immense stretches of time, some of these molecular arrangements gained a simple but crucial ability: the ability to copy themselves. These early self-replicating systems were not alive in any meaningful sense we would recognize today, but they represented a turning point. For the first time, matter was beginning to organize itself in a way that allowed information to persist and change over generations. From these beginnings emerged the first true living organisms, microscopic single-celled life forms that drifted through the oceans, feeding on chemical energy and dividing slowly. They had no awareness, no intention, and no complexity, yet they carried within them the foundation of all future life on Earth. For hundreds of millions of years, these organisms were the only form of life on the planet. The oceans during this time were silent, dark, and largely unchanged on the surface. There were no plants, no animals, and no visible movement beyond waves and storms. Life existed entirely at the microscopic level, hidden from view, quietly reshaping the chemistry of the planet without anyone to observe it. Gradually, some of these organisms developed a new way of surviving. Instead of relying solely on chemical reactions near the ocean floor, they began to use energy from the sun. Through a process that would later be known as photosynthesis, these organisms captured sunlight and used it to produce energy, releasing oxygen as a byproduct. At first, this oxygen did not accumulate. It reacted quickly with dissolved metals in the oceans, forming rust-like compounds that settled to the seafloor. For millions of years, oxygen production and oxygen absorption remained in balance, and the atmosphere above remained unchanged. But the process continued, slowly and persistently. Eventually, the oceans reached a point where they could no longer absorb all the oxygen being produced. The excess began to escape into the atmosphere. This marked the beginning of one of the most significant transformations in Earth's history: the Great Oxygenation Event. As oxygen levels rose, the planet began to change in subtle but far-reaching ways. The sky took on new colors. Chemical reactions in the atmosphere shifted. And for many existing organisms, oxygen proved to be toxic, leading to widespread extinction among early life forms. Yet for others, this new environment offered opportunity. Life adapted, diversified, and grew more complex. With increasing oxygen in the atmosphere, another crucial development took place. High-energy sunlight interacted with oxygen molecules, forming ozone. Over time, an ozone layer developed high above the surface, creating a protective barrier that absorbed harmful ultraviolet radiation from the sun. For the first time in Earth's history, the surface of the planet was no longer entirely lethal to life. Still, progress was not smooth. As oxygen levels continued to rise, greenhouse gases in the atmosphere declined. Temperatures dropped. Ice began to spread from the poles toward the equator. Over long periods, Earth entered one of its most extreme climate states, a condition now known as snowball Earth. Glaciers expanded across continents. Oceans froze at the surface. From space, Earth would have appeared pale and almost entirely white, reflecting sunlight back into space and reinforcing the cold. Life once again retreated to the few environments where liquid water remained, surviving beneath ice and near volcanic heat sources. Yet even in this frozen state, Earth was not inactive. Deep below the ice, volcanic activity continued uninterrupted. Carbon dioxide was released into the atmosphere, slowly accumulating because weathering processes had come to a halt beneath the global ice cover. Over millions of years, this buildup strengthened the greenhouse effect, trapping heat and gradually warming the planet. At last, the ice began to melt. As glaciers retreated, enormous amounts of fresh water flooded the oceans. Chemical reactions within the melting ice released additional oxygen into the atmosphere, accelerating biological and environmental change. The planet shifted rapidly from extreme cold to a warmer, more dynamic state. Earth had survived another test, and in the newly oxygen-rich oceans, life was about to change in ways that would reshape the planet forever. As the planet emerged from its frozen state, the oceans became places of movement and renewal. Sunlight once again reached the surface waters, warming them gently, while deeper regions remained cool and rich in nutrients. Oxygen levels continued to rise, not suddenly but steadily, creating conditions that allowed life to experiment in new and unexpected ways. For hundreds of millions of years, life on Earth had remained simple and small, confined to single cells drifting through the oceans. But now something changed. Genetic variation increased. Energy became more readily available. And the boundaries that once limited biological complexity began to loosen. Around 600 million years ago, life entered a period of rapid transformation known as the Cambrian explosion. In a relatively short span of geological time, the oceans filled with an extraordinary diversity of organisms. Bodies became larger, shapes became more complex. Structures such as shells, limbs, and primitive eyes appeared for the first time. The seafloor, once quiet and largely empty, turned into a living landscape. Soft sediments were disturbed by crawling creatures. Burrows formed beneath the surface. Water columns filled with drifting life. For the first time, ecosystems resembling those we recognize today began to take shape. With complexity came competition. Some organisms developed hard outer shells for protection. Others evolved sharp appendages and specialized mouthparts designed for capturing prey. Movement became faster and more purposeful. The ocean was no longer a passive environment. It was an arena of survival, adaptation, and constant change. Among the dominant predators of this era was a creature known as Anomalocaris. With its large compound eyes and grasping limbs, it moved through the water with efficiency and control. To smaller organisms, it represented a new kind of threat, one that could see, pursue, and consume them. The presence of such predators drove further evolutionary innovation, pushing prey species to develop better defenses, camouflage, and awareness. Over time, balance emerged, food webs formed. Energy flowed from microscopic producers to larger consumers. The oceans stabilized into complex, layered systems where countless species interacted in subtle and interconnected ways. As millions of years passed, some organisms began to explore environments closer to the surface, where sunlight was stronger and conditions changed more rapidly. Tides exposed shallow waters to air. Seasonal changes created fluctuating environments that rewarded flexibility and resilience. In these transitional zones, certain fish-like creatures began to change. Their fins grew stronger, supported by internal bones. Their bodies flattened slightly, allowing them to rest against the seafloor. Some developed primitive lungs, enabling them to survive brief periods in oxygen-poor water or even outside water entirely. One such creature, known as Tiktaalik, lived in shallow, swamp-like environments where land and water blurred together. It could push its body upward, using its fins almost like limbs, lifting its head to breathe air when necessary. Tiktaalik did not live fully on land, but it represented a crucial step, a bridge between aquatic life and the terrestrial world. The movement onto land was not easy. The surface of Earth was exposed to intense solar radiation, drying winds, and dramatic temperature changes. Without protection, survival was difficult. Yet life persisted, adapting slowly, generation by generation. Plants were among the first to truly establish themselves on land. Simple moss-like organisms spread across damp surfaces, breaking down rock and forming the earliest soils. Over time, taller plants emerged, developing vascular systems that allowed them to transport water and nutrients efficiently. Forests began to appear, transforming the planet's surface. As plants spread, they altered the atmosphere. Oxygen levels increased further, supporting larger and more energy-demanding animals. Insects grew in size, some reaching proportions that would seem impossible today. Dragonfly-like creatures with wingspans comparable to modern birds filled the air, supported by the high oxygen content of the atmosphere. With plants and insects in place, more complex land animals followed. Amphibians moved between water and land, while reptiles evolved a key innovation, the amniotic egg. This allowed embryos to develop in a protected environment, freeing reproduction from dependence on water. Life could now fully colonize the continents. Earth, once dominated by oceans alone, had become a planet of land, air, and sea, each hosting diverse and interconnected ecosystems. But stability on Earth is always temporary. As continents continued to drift and climates shifted, the planet moved once again toward crisis. Volcanic activity intensified in certain regions, releasing vast amounts of gas into the atmosphere. Temperatures fluctuated. Ocean chemistry changed. The delicate balance that life depended upon began to falter. Around 250 million years ago, Earth entered the most devastating mass extinction in its history. Massive volcanic eruptions in what is now Siberia flooded the atmosphere with carbon dioxide and toxic gases. Acid rain fell across the land. Oceans lost their oxygen. Entire ecosystems collapsed. Nearly all life on Earth disappeared. The planet fell quiet. For a time it seemed as though Earth might never recover. Yet beneath the silence, life endured. In small scattered refuges, a few resilient species survived. And from these survivors, the next great chapter of Earth's story was about to begin. As the Earth slowly recovered from its greatest catastrophe, the planet entered a long period of healing. The atmosphere stabilized, temperatures gradually evened out, rain returned to the land, and new plants began to spread across the empty landscapes. What had once been a world of death became a quiet stage for renewal. From the few survivors of the mass extinction, life began to diversify once again. Small reptiles, once overshadowed by earlier dominant species, found space to grow and adapt. Over millions of years, these reptiles evolved into a wide range of forms, shapes, and sizes, creatures that would eventually come to dominate the planet. This was the beginning of the age of dinosaurs. The continents at this time were still connected, forming a vast supercontinent known as Pangaea. With no large oceans to separate land masses, animals were free to migrate across enormous distances. Climate patterns were different from today, warmer, more uniform, with fewer extreme temperature differences between the equator and the poles. Vegetation flourished. Ferns, cycads, and conifer forest covered much of the land. Rivers flowed slowly across broad plains. Shallow seas bordered the continents, rich with marine life. It was a world that offered abundance, and dinosaurs were perfectly suited to take advantage of it. Some species grew massive, their bodies supported by powerful bones and slow, deliberate movement. These giant herbivores spent their days feeding on vast quantities of plant matter, shaping the environment around them simply by existing. As they moved, they trampled forests, opened pathways, and redistributed nutrients across the land. Others evolved into agile predators, equipped with sharp teeth, strong jaws, and keen senses. They hunted in forests, along riverbanks, and across open plains. Over time, complex behaviors emerged: territorial displays, mating rituals, and possibly even forms of social cooperation. Dinosaurs ruled not just the land, but the skies and the seas as well. In the air, early flying reptiles known as pterosaurs mastered powered flight. Their wings, formed by stretched membranes of skin, allowed them to glide over oceans and coastlines, scanning the surface below for fish and small animals. Some grew enormous, with wingspans rivaling those of small aircraft, while others remained lightweight and agile, adapted for speed and maneuverability. In the oceans, reptiles returned to the water, evolving into powerful swimmers such as ichthyosaurs and plesiosaurs. Their bodies became streamlined, their limbs transformed into flippers, and their movements echoed those of modern dolphins and whales. These marine reptiles dominated the seas for millions of years, becoming apex predators in their own right. For more than 160 million years, dinosaurs shaped the face of Earth. Continents slowly drifted apart. Mountain ranges rose and eroded. Sea levels advanced and retreated. Yet through all these changes, dinosaurs adapted, diversified, and endured. Beneath their dominance, however, another story was quietly unfolding. Small mammals existed alongside the dinosaurs, but they lived mostly in the shadows. They were small, nocturnal, and cautious. Many burrowed underground or lived in trees, emerging mainly at night to avoid predators. Their bodies were covered in fur, helping them regulate temperature. Their brains slowly grew more complex, favoring learning and adaptability over sheer size. For a long time, mammals remained insignificant in appearance, easily overlooked in a world ruled by giants. But Earth was never a stable world. Far beyond the planet, in the cold reaches of space, an object was already moving. A massive asteroid formed in the early days of the solar system had been traveling through space for millions of years. Its path was silent and unchanging until gravity pulled it toward Earth. 65 million years ago, this object entered Earth's atmosphere at unimaginable speed. In a fraction of a second, everything changed. The asteroid struck what is now the Yucatan Peninsula with a force unlike anything the planet had experienced since its formation. The impact released energy equivalent to billions of nuclear weapons. Rock vaporized instantly. Shock waves rippled across the globe. Earth itself seemed to shudder. Molten debris was thrown high into the atmosphere, spreading across the planet. As it fell back to the surface, it heated the air to extreme temperatures, igniting fires across entire continents. Forests burned, skies darkened. The sun disappeared behind thick clouds of dust and ash. For months and possibly years, sunlight was blocked. Plants died. Food chains collapsed. The great dinosaurs, so dominant for so long, could not survive the sudden and drastic change. One by one, they vanished. But once again, life found a way. The small mammals hidden underground and adapted to scarcity survived. They fed on seeds, insects, and anything they could find. In a world suddenly emptied of giants, opportunity emerged. As the dust slowly settled and sunlight returned, the planet entered a new era. Forests regrew, insects returned, mammals expanded into the vacant ecological niches, evolving into larger and more diverse forms. The age of dinosaurs had ended. The age of mammals had begun. After the extinction that ended the age of dinosaurs, Earth entered a long period of transformation. The planet did not recover quickly. Instead, it healed slowly over millions of years, as life cautiously expanded into the empty spaces left behind. Forests spread across the continents once more. New plant species appeared, forming layered ecosystems that supported insects, birds, and small animals. The climate was generally warm, with no permanent ice at the poles. Oceans remained high, covering large areas of land and shaping coastlines far different from those we know today. Mammals, once small and hidden, began to diversify. Some remained tiny and nocturnal, while others grew larger, experimenting with new body plans and behaviors. Hooves, claws, and specialized teeth evolved, allowing mammals to exploit a wide variety of food sources. Over time, mammals adapted to nearly every environment, from dense forests to open plains, from underground burrows to shallow coastal waters. In the oceans, some mammals returned to the water, eventually evolving into whales and dolphins. Their bodies became streamlined, their limbs transformed into flippers, and their hearing adapted to life beneath the surface. In the skies, bats evolved powered flight, navigating the darkness with echolocation. But one group of mammals followed a quieter path. In the forests, early primates appeared. These animals were small, agile, and highly observant. Their hands were capable of grasping branches, and their eyes faced forward, allowing for depth perception. Life in the trees favored coordination, memory, and problem-solving, traits that would become increasingly important over time. For millions of years, these primates lived unnoticed, adapting gradually as forests expanded and retreated with changing climates. Earth's continents continued to drift, reshaping ocean currents and altering global weather patterns. These slow geological processes influenced rainfall, temperature, and vegetation, subtly guiding the direction of evolution. Around 30 million years ago, the world began to cool. Ice formed at the poles. Seasonal changes became more pronounced. Forests shrank in some regions, replaced by open grasslands and savannas. In Africa, these environmental shifts created new challenges for primates adapted to life in trees. Some species began spending more time on the ground. Walking upright offered advantages: the ability to see over tall grass, to travel long distances efficiently, and to free the hands for carrying food or using simple tools. Over many generations, bodies changed. Spines straightened, hips reshaped, legs lengthened. This transition did not happen suddenly. It unfolded slowly, through countless small adaptations, shaped by survival rather than intention. Early human ancestors such as Australopithecus walked between trees and open land, balancing old behaviors with new ones. Later, Homo erectus emerged, capable of traveling vast distances. Fire was controlled, Simple tools were refined. Social structures became more complex. For the first time, a species began to shape its environment deliberately. As Earth continued to change, so did humans. Ice ages came and went, lowering sea levels and connecting continents through land bridges. Humans migrated across Africa, into Asia, Europe, and eventually the Americas. They adapted to deserts, forests, tundra, and coastlines, learning to survive in nearly every environment on the planet. Around 70,000 years ago, modern humans, Homo sapiens, began to spread widely. Language, art, and symbolic thinking emerged. Stories were told. Knowledge was passed down through generations. Culture became as important as biology. Through all of this, Earth remained an active participant. Mountain ranges rose as tectonic plates collided. Rivers carved valleys. Glaciers reshaped landscapes. Volcanic eruptions altered climates. The planet continued its slow, powerful movements, indifferent to individual lives, yet essential to every story. Today we live in a brief moment of geological calm, but the forces that shaped Earth are still present beneath our feet and above our heads. The continents are still moving. The climate is still changing. Life continues to adapt. Humans are now part of Earth's story, not separate from it, but deeply woven into its ongoing evolution. And just as life survived ice ages, mass extinctions, and planetary upheaval, the story of Earth continues, quiet and unfinished, stretching far beyond the present moment. As humans spread across the planet, Earth continued its slow and indifferent rhythms. The forces that shaped mountains, oceans, and continents did not stop for civilization. Ice ages returned, retreating and advancing like a deep, steady breath taken by the planet itself. Massive lead sheets formed across the northern continents, stretching for thousands of kilometers. Glaciers moved slowly, grinding rock into dust, carving valleys, reshaping entire landscapes. Sea levels dropped as vast amounts of water became locked in ice, revealing land bridges that connected continents once again. These frozen corridors allowed humans and animals to migrate into new lands. Across what is now the Bering Strait, people walked from Asia into the Americas, following herds, adapting to harsh cold and long winters. Fire, clothing, and cooperation made survival possible in environments that once seemed uninhabitable. When the ice retreated, the world changed again. Rivers flooded newly exposed land, forests expanded northward, deserts shifted, animals followed the vegetation, and humans followed the animals. Slowly, societies became more settled. Agriculture emerged. Villages grew into cities. Stone turned into metal. Stories turned into written history. Yet even as civilizations rose, Earth remained vastly more powerful. Volcanoes continued to erupt, reshaping regions in moments. Earthquakes shifted coastlines without warning. Storms formed over warm oceans, releasing energy accumulated over months or years. The planet reminded its inhabitants, again and again, that stability was always temporary. Over time, humans learned to observe the sky. They tracked the movement of stars, the rhythm of seasons, the cycles of the moon. They learned that Earth was not the center of everything, but part of a much larger system. A planet orbiting a star, one among billions in a galaxy that itself drifted through space. This realization changed how humans saw their world. Earth was no longer just land beneath their feet. It became a fragile sphere, suspended in darkness, protected by a thin atmosphere and a delicate balance of forces. Water, air, temperature, and chemistry align just enough to allow life to exist. And for a brief moment in cosmic time, that balance remains. Today, Earth is approximately 4.5 billion years old. It has survived impacts, freezes, fires, and extinctions. It has rebuilt itself countless times. The rocks beneath our cities carry the memory of oceans long vanished. The air we breathe has passed through ancient forests and microscopic organisms. Nothing on this planet is truly separate from its past. Even now, the story continues beneath the surface. Tectonic plates still drift, only a few centimeters per year, yet powerful enough to reshape the planet over time. Magma moves slowly through the mantle. New crust forms along ocean ridges. Old crust sinks back into the depths. Far in the future, continents will collide again. Mountains will rise where seas once lay. Oceans will close and reopen. The sun will grow brighter. Climates will shift beyond anything humans have known. Life will adapt, or it will end and begin again in new forms. Because Earth has never been static. It is a living system of motion and change, shaped not by intention but by time. And time moves on, quietly, endlessly. For now we exist in a narrow window, a calm chapter between extremes. A moment where oceans are liquid, air is breathable, and the surface is alive with complexity. A moment rare enough that, as far as we know, it has happened nowhere else. This is our moment. Not permanent, not guaranteed, but real. And as you listen, as images drift slowly across the screen, remember this. Every mountain once lay beneath the sea. Every breath carries the echo of ancient life, and every second that passes becomes part of Earth's unbroken story. The planet will continue long after us, and somewhere far in the future this chapter, our chapter, will be nothing more than a thin line in stone, quietly resting beneath layers yet to come. As night falls over the planet, Earth continues its motion without pause. Cities glow softly from orbit, thin lines of light tracing coastlines and rivers. Clouds drift slowly across continents, moved by winds that have followed similar paths for millions of years. From space, Earth appears calm, silent, whole. Yet beneath this quiet surface, time continues its work. Rocks slowly fracture under pressure. Mountains rise almost imperceptibly, only to be worn down again by rain, ice, and gravity. Rivers carve paths not over years, but over ages. Every landscape you see is temporary, even if it appears unchanging within a human lifetime. The moon still circles the Earth, just as it has since the earliest days of the planet. Its gravity gently pulls on the oceans, creating tides that rise and fall in steady rhythm. These movements slow Earth's rotation, lengthening our days by tiny fractions of a second, changes so small they pass unnoticed, yet inevitable. Far above, the atmosphere protects life with quiet efficiency. It absorbs radiation, distributes heat, and carries water across the globe. This thin layer of gas, fragile and easily disturbed, is all that separates the living world from the vacuum of space. For most of Earth's history, there were no observers, no eyes to watch the sunrise, no minds to question the past, no voices to tell stories. Life existed anyway. It adapted without awareness, responding only to pressure, chance, and time. Species appeared and disappeared, leaving behind fossils, chemical traces, and altered environments. Entire worlds rose and fell without memory or meaning, except what we now assign to them. Humanity is different only in its awareness. We look back, we imagine forward, we try to understand. Yet even with all our knowledge, we remain part of the same system, dependent on the same cycles, vulnerable to the same forces. The ground beneath our feet is not solid in the long view. It is a moving surface atop a restless planet. In the distant future, long after cities fade and languages are forgotten, Earth will continue. Ice may return, covering continents once more, or heat may dominate, drying oceans and thinning forests. The exact path is uncertain, but change itself is guaranteed. Hundreds of millions of years from now, the continents will form new shapes. Familiar coastlines will vanish. Mountain ranges will rise where plains once stretched. New species may walk the land, shaped or none at all. And far beyond that, the sun itself will change. It will grow brighter, warmer, altering the delicate balance that allows liquid water to exist. Oceans may slowly evaporate, the atmosphere may thin. Earth's surface will transform into something unfamiliar, shaped by forces older than life itself. This is not destruction in a dramatic sense. It is simply time doing what it has always done. As you listen, as images drift slowly across the screen, there is no urgency here, no demand for attention, only the reminder that everything, mountains, oceans, civilizations, even thoughts, exist within a flow far larger than itself. Sleep comes easily when we remember this, that we are brief, that the planet is ancient and that change is the natural state of all things. Earth does not rush, it does not hesitate, it moves forward, quietly, endlessly. And somewhere within that motion, for a short while, we are here, listening, resting, breathing, part of a story that began long before us and will continue long after we are gone. And at the end of this long journey, the Earth continues to turn in silence. Continents shift slowly, without urgency. Oceans hold the memory of millions of years in their depths, and the winds keep moving endlessly across the surface of the planet. We may not always notice it, but with every breath we take, we are living inside a story that began more than 4.5 billion years ago. Material born in distant stars became rock and water and life, and eventually beings capable of thought and reflection. All wars and discoveries, all fears and hopes are only brief moments in the vast history of Earth. The planet existed long before us, and it will continue long after we are gone. When night falls, the Earth does not stop spinning, it simply grows quieter. The oceans keep their gentle motion, volcanoes breathe deep beneath the surface, and starlight continues to fall softly upon the world. This story does not truly end, but this telling of it comes to rest here. Now let time keep flowing, let the Earth follow its path, and allow yourself to simply listen, quietly,